And welcome back, and it is the 11th of March, further maths 5 a day, and let's just go straight into the first question. Right, so what do we have? So solve, and this is just a pretty standard, can you solve a quadratic equation, isn't it? So whichever method you want, the temptation here is to try and factorize it, which I think I can. I'm going to give that a go in a second. Although I do say in class when I'm teaching this, if you don't see it in the first 10 seconds, just use a quadratic formula. It's quicker, you get good at doing it, and it's better than messing around. But having said all of that, I'm going to give it a go at factorising because I think it works. So I've got 2x and x because I know that's my way of making up 2x squared. All these numbers are plus, which means I know that these are plus in the middle, so that makes it a bit easier. And so really the question is, do I put the 2 here or do I put the 2 here? Now because I want 5, I know 5 is 2 times 2 plus 1, so therefore that's going to be my factorisation. That is equal to 0, which means that x is equal to minus a half, or x is equal to minus 2. Not too bad. First question done. Next question. The line passing through 1p and 5, 1 has a gradient of 3/4, find p. Okay, a couple of ways of doing this. I'm just going to do the really obvious. Let's just set up my equation. So the change in my y is 1 minus p. The change in my x is 5 minus 1, which is 4, and that's equal to 3/4. Wow, they made this balance out nice and easy, didn't they? So therefore 1 minus p must equal 3. In other words, multiply both sides by 4. What do I take away from 1 to get 3? Well, it's going to be minus 2. So therefore my p is going to be equal to minus 2. Good question. I like that question. Next question. The point 4a is an invariant. Now, the point invariant means it does not change when you apply a transformation to it. So I'm going to do that. So I'm going to do minus 5 minus 2, 3, 2 times 4a. And once I apply the transformation, I end up where I started because it's invariant. And then I can follow the maths through. Well, I'm only going to do the bottom line because I need the a in the equation. So therefore, it must be the case that 3 times 4, and again, I'm just doing this times this. So 3 times 4 is 12 plus 2a is equal to a, which means take away a from both sides, which means a is equal to minus 12. That fell out relatively easily, didn't it? Good question. Next question. This feels very much like an A-level question as well. So these are good questions to understand. Angle theta is obtuse. So straight away, actually not straight away, let's carry on. So work out the value of sine theta. So I knew where this question was going because I've seen these questions before. So cos theta does this. And then cos theta comes up, where am I getting to? So I need to get to here. So cos theta comes up and comes down for here. And the reason I've done that is because obtuse angles are between 90 and 180. So in other words, and this is the important point, I know my sine graph that I care about is this bit here. Right, we'll come back to why I said that in a minute. If I know that cos theta equals 12 over 13, I'm basically ignoring the negatives. I think about the negatives later. That means I know I have a right angle triangle, whereby there's my angle, and there's my right angle. This is 12 adjacent over hypotenuse is 12 over 13, which means that this here is 13 squared minus 12 squared square rooted, which is 5. It's a 5, 12, 13 triangle. By the way, just like knowing your squares, 5, 12, 13, 3, 4, 5 triangles, good thing to keep in the back of your head. Anyway, point is, I now know that sine theta is opposite, which is 5, over hypotenuse, which is 13. Next question, is it positive or negative? You can see here, it's above the axis, so therefore it's positive. So therefore sine theta equals 5 over 13. Next and final question today. A curve has equations, so it's a bit similar to yesterday's question, I think this might be. Y equals something. At the point Q, the tangent is parallel to the line with y equals minus 3x. Oh, this is clever. Okay, it's not the same as yesterday, it's a different wording. If it's parallel, it means it has the same gradient, which means the gradient is the number before the x, which is minus 3. So what it's really saying is, can you differentiate the equation, which of course I can. That's going to give me 8x minus 1. And can you set that equal to minus 3? Which again, of course I can. Okay, so the next question is, how do I solve it? Well, of course, this is just a fairly straightforward linear equation, isn't it? So add 1 to both sides, tells me that 8x equals, well, minus 3 plus 1 is minus 2, divided by 8 is going to give me minus a quarter. That's my x value, but it wants the coordinates of Q. So I'm going to have to put my x value back into here. So therefore my y value, and again, just be careful, it's really easy to mess this up at the end. So it's 4 times minus a quarter squared, which is a 16th. Minus minus is a plus a quarter, and then plus 1. Well, 4 over 16 is a quarter, so it's a quarter plus 1, which is going to be 6 quarters, otherwise known as 3 over 2, so that's 3 over 2. So therefore, just to make sure I've been absolutely clear, Q is going to be equal to minus a quarter, 3 over 2. Always pull the answer back out at the end. And that's it, today done. The last few days have been really good, and like a really mix of different sorts of questions, testing you in different ways. Let me know how you did. Do like and subscribe, and I'll see you for the next one. Thanks all.